Tree representation. A tree data system can be represented in two methods. List represented. So left child, right sibling representation. Consider the following tree: A, B, C, D, E, E, F, G, H, I, J, K. Tree with 11 nodes and 10 edges. In any tree with n nodes, there will be a maximum of n minus 1 edges. In the tree, every individual element is called as node. List representation. In this, we use two types of nodes, one for representing node with data called data node, and another for representing only reference called the reference node. We start with the data node from the root node in the tree. Then it is linked to the internal node through a reference node, which is further linked to any other node directly. This process repeats for all the nodes in the tree. The above example tree can be represented using the list representation as follows: A, then B, then C, then F, then E, I, J, then it is become C, C become another branch H and K. Left child and right sibling representation. In this representation, we use the list with one type of the node which consists of three fields, namely data field, left child reference field, and right sibling reference field. Data field stores the actual value of the node. Left reference field stores the address of the left child, and right references told the right so the address of the right sibling node. Graphical representation of the node is as follows: data left child, right sibling. In this representation, every node data field stores the actual value of the node. If that node has a left child, then left reference field stores the address of the left child node, otherwise stores null. In the node has a right sibling, then right reference field stores the address of the right sibling node, otherwise stores null. The above example tree can be represented using the left child, right child siblings as follows: A, B, C, E, E, and C and E become G. This is a null. Right child J, null, K, null, H, G. Real-time application and example of the tree structure. Example of the Unix file system: root, bin, div, etc. Home, lib, where, volume, temp. Bin will divide into 4 directories. Val will divide the Oracle sales productions. The Unix file system hierarchy: HTML DOM structure. The HTML DOM views as HTML views as the tree structure called a node tree. All nodes can be accessed through the tree, and their content can be modified and deleted, and new elements can be created. The new tree node tree shown below at the bottom shows the nodes associated with the following: mypage.html and a connection between them. The tree nodes, the document node, and branches out the text node at the lowest level. My web page, welcome to my web page. Document, root element HTML, head, body, and title, and text element H1 text. DOM represented in the example table. Table rows tr, td, td, static row. Some names are defined. Properties of the document object. Let us see properties of the document object that can be accessed and modified with the document. Document anchor form link. That form may be text area, checkbox, radio, select, reset button, and select as the option button. See that Devin kite, grandparent, greet grandparents. Okay, SQL Server display the hierarchical data from a tree. It is common hierarchy of a tree structure table in the SQL command model data. See this: root, child 1, child 2, node depth 0, 1, 2, 2, defining 2, hierarchical display data. But when it becomes to display the raw data, it is hard to identify the hierarchical form. Node ID, parent null, name root, and 2 depth node ID we have to mention. Non-hierarchical display. Now we can easily see the hierarchical structure of our data. Employee data relationship. Okay, this is non-hierarchical display format. That is the hierarchical display format. Now employee department relationship. Manager name null will be there. A manager name all A will be there. Okay, now collected select are from employee name. Terminology of the binary node. It is represents the termination point in a tree. Road, tree topmost node. Parent, each node apart from the node in a tree that has at least one subnode. It is called the parent node. Child, leaf node, height of the node, depth of the node, height of the tree, depth of the tree. Okay, this is the one, depth of the tree. Height and the depth of the each node, degree of the node.